Welcome to another episode of InRange. This is going to be a different one. If you didn't notice from the actual thumbnail of this video, this is one that's going to focus on cybersecurity. But I honestly think and have long thought that the intersection of cybersecurity and physical security and privacy in our world are so interconnected that I feel that it's appropriate for this channel. And I've done a number of videos on InRange about topics like this in the past, but frankly, it's been a while. Some of you out there I know are full-on InfoSec specialists, and this is going to be old news to you, but maybe it'll be a good summary for you. And for those of you that are not, I'm going to try and make this a very approachable topic. So what I'm going to talk about today is the Solarwinds Sunburst hack that happened recently. It's been all over the news about how this has exploited multiple levels of the US government, amongst other things. And that's true, but the media likes to play things out in a way that gets clicks. And I'm not going to go ahead and tell you that this is not a big deal. It is a big deal. This is a significant breach, but I think I'll give you a little more of a nuanced impression, being someone that's worked in that industry for a long time. So for those of you that don't know, there's been a giant breach amongst many networks, including many layers of the US government, including the Energy Department and others, in which it was discovered in just recently, and it is currently being attributed to Cozy Bear, which is a Russian hacking collective, and all indications seem to indicate that that's probably correct. The breach of this level certainly appears to be something on the nation-state level, if nothing else, if not to be attributed to Russia. However, the idea that it's not Russia and Cozy Bear would be highly unlikely. So here's what happened. Solarwinds used to be a smaller company that dealt with essentially network IT mapping tools, and I used it way back when on some of my corporate jobs. And when you build a network, you need to do discovery on the network. Networks tend to get bigger than you want them to be, and you lose track of what a network actually is. And so Solarwinds made essentially mapping tools that allowed you to discover on your network, figure out what hosts are on your network, what nodes are on your network, and make somewhat of an automated map of what your network looks like. Now, they've expanded well beyond that, and they have this platform called Orion, which I personally have not used, but it appears to be like Steam for a bunch of different IT tools. What I mean by that is, it's a place where they repackage and distribute software from not just SolarWinds, but maybe other developers as well, that are then rebranded under the SolarWinds name, under this Orion update server / distribution server. It'd be like if you went to Steam and wanted to download a copy of a game. Most of the games that are on Steam are not made by Valve, but Valve is the company running Steam, and then Steam is the distribution engine for a large variety of third-party developers, large and indie, to get that to you. So think of this SolarWinds Orion thing as akin to Steam. So corporations go to the SolarWinds Orion server and acquire the tools that they think they need for running their network, and they get their updates from this Orion server, just like you would get updates for one of your games. Cyberpunk 2077 being one of the ones heavily updated recently, if you haven't been paying attention, and boy, how timely. So here's what happened. FireEye is another security company, and I have to admit to you, I'm not a big fan of them. They have been always very forceful in getting their way into your networks from the top end. So executives would inevitably come to you as an InfoSec guy and go, wow, this FireEye thing seems to solve all the problems in the world. We need FireEye. And anything that solves all the problems in the world doesn't. But I digress. That's another topic for another time. The reality is FireEye is who actually detected this breach. So somewhere around March of 2020, an update came out of SolarWinds, but the reality is someone was in the SolarWinds network and in the update server, and they embedded about 4,000 lines of malicious code into a build. That breach and that occurrence happened before March of 2020. But that code was sitting there. These 4,000 lines of code were laying there waiting for their day for the SolarWinds crew or whoever to create a new build as an update and then distribute it through their Orion. You have to be aware that I'm making this video at the end of December 2020, and things like this develop over time. And so some of what I'm telling you today may not be wholly accurate a couple months from now, because these types of breaches take a lot of research to determine what's occurred. So at any rate, some attacker got into the SolarWinds network. Now, it is really interesting to note that in 2019, there was a researcher who detected a severe vulnerability in that the default password for this, exposed to the internet, mind you, was SolarWinds 123. Now, I've said on this channel a number of times, one of the best things you can do for your internet security is to improve your password management and your passwords. And SolarWinds, being an IT tools company, not doing something better than SolarWinds 123 with inappropriate exposure to the internet, it makes them extremely deficient in their tasks when it comes to security. As soon as people realized that they were doing things like that, there should have been some sort of purge of this software off of every network on the planet, and not using that Orion server, but that's now how corporate America works. So, at any rate, this code was built around March of 2020, and then some number of the 18,000 customers downloaded this code. And then upon running this code on their network to do their normal SolarWinds work, whatever that was, it essentially instigated this 4,000 lines of malicious code, which then embedded itself in other machines in the network. And those then beacon out from the network that's been breached to what are called command and control servers, or CNC servers. So you got to think about how big this issue is. So a CNC or a command bot or a botnet or a command and control server is another compromised machine generally outside of the network that's being breached. So think of your network as a bubble, and then there's other machines compromised on the internet. And then once your bubble breaks because it's been compromised by these 4,000 lines of malicious code, those machines talk to those CNC machines, those command and control servers that are also controlled hosts by the attacker. And then those machines work as a proxy, for lack of a better term, for the attacker to talk to the devices inside your network. So this is huge because the person or the persons or the nation state that instigated this attack meant that they had a large number of already compromised zombie hosts or CNC machines existing all over the internet, because one of the very interesting things about this attack was that once your network was compromised, it didn't talk to command and control servers that were far flung. It didn't talk to a command and control server that sat in Russia or India if you were in the United States, for example. It was smart enough to only talk to CNCs or controlled hosts outside of your network within the general geographic region of which you existed. This is a way to most likely evade a lot of really simplistic intrusion detection servers that would be like, whoa, why is there suddenly traffic going from our network to Russia? We don't really do any business with Russia. That kind of stuff alerts pretty quickly and beacons really easily. But some simple server on the inside talking to another machine on the outside on SSL, as long as it's not something that's considered a weird region for your normal business model, doesn't really get detected. Well, not in most networks. We'll get to that more. So this tells you that the attacker had lots of compromised hosts all over the internet geographically for whoever their targets were, and that they were able to not only penetrate the SolarWinds network and the SolarWinds update server, that they embedded 4,000 lines of well-coded malicious code. Then they then had the patience to wait for this to get built and then updated and pretty much wait for their harvest. So imagine it's like they went out and planted the seeds and then waited for it to germinate. And one day suddenly they started seeing stuff coming back to them, and they knew that they started compromising hosts and servers. At that point, you would connect to your CNCs or whatever your proxies were to then talk to the machines that are compromised within your attacked network and try to determine what even you attacked. Because as you were deploying this hack through the update server from SolarWinds, you didn't know which of the 18,000 customers were going to actually download and install the update. And you didn't know how many of the 18,000 customers were going to download and install the update that had inappropriate security measures on their network to detect the breach once it occurred. Well, that's where FireEye comes in. FireEye actually got breached another way. They got attacked and breached and knew that they had an intrusion, and upon trying to do an investigation upon the intrusion that happened not related to the SolarWinds Sunburst, they detected all this anomalous traffic that had been coming out of FireEye. They alerted the US government. The government sat on this for about a month because the government realized that large amounts of the US government had been breached in this attack. And then it sort of leaked out into the world about a month ago. And the reality of the situation set in that this is a huge, large, likely nation-state attack that has been sitting essentially as an advanced persistent threat inside of multiple networks, including high levels of the US government, since probably March of 2020. Now, here's what's interesting. We hear the word attack, but this really wasn't an attack. The intention of this was espionage, or maybe planting other malicious code in networks that have been breached. So when you have access to an external network that you're interested in, you don't want to be detected. You want to sit there and watch. And that's exactly what was being done with this SolarWinds attack. They weren't there to cause more problems or to cause an outage, and that's how they didn't get detected. Their plan was to sit there and see what was going on the local network and watch all the stuff on the local network and potentially steal a lot of intellectual property out of those local networks. So the longer that hack could go on and the longer that their breach could be maintained without detection, the longer they could do more and actually do the espionage they're looking to do. So this isn't to say that, let's say all 18,000 customers downloaded and installed this. That doesn't mean that all 18,000 customers have been breached, and it doesn't mean that all 18,000 customers actually have been spied upon. When this stuff starts beaconing back to the attacker, they're going to look at which networks are interesting to them and which ones are not. Let's say they breached a local company that makes stickers. They probably don't care much about that unless they want to use some of the servers on that sticker company's network as another command and control server. Other than that, the espionage elements there are minimalistic, if not useless. But if they see a beacon coming from the US Department of Energy, they're going to be very interested in what's going on that network, and they're going to sit there and latently try to watch as much as they can. Once you're inside of a network perimeter and you have control of this host, you can then start looking around the rest of the network very carefully, if you know what you're doing, to ensure that to look for other vulnerabilities. So you'll use that as a jumping place to jump to other machines in that corporate network. Now, if you're not careful, that's where you'll likely get detected, because a lot of corporations have put in sometimes complex, sometimes simplistic detection services on local hosts, meaning on the machines. And so if they suddenly see a machine that normally shouldn't, doing, like, let's say, a port scan of that machine or port scanning an entire subnet of IP addresses, they're going to be like, whoa, why is that machine doing that? So that kind of thing means that the person or the persons that are running the compromised host need to be smart and know what they're doing to not be detected in the process. Now, think about this. If you're sitting on a machine and using it for the purposes of espionage, and one of the things you're able to pull out of that are usernames and passwords, then you don't need to compromise other hosts in the network potentially to get into them. If you have the username and passwords and that machine can get to the other machines with no restrictions and controls, let's say SSH or HTTPS, a web server, and you have a username and password, there would probably be no anomaly detected by using that username and password to get into that machine. Then once you're in that machine, you would then download other malicious code and make that another machine you control on the corporate network. Here's the point I'm getting to. Once you're in, you're in. And once you're in for nearly a year, you're really in for nearly a year, and you can do a lot in that time. There is no way to understand the breadth and scope of this attack or this espionage attack in terms of what was done in these internal networks once they were breached with this Solarwinds Sunburst. Hopefully that made some sense of explaining the overall gist of what occurred. But now what I'm going to do is give you my take on what this really means. And the media is going crazy about the most prominent, largest hack that's ever occurred, and all of these things. And I would say that this might be one of the most prominent hacks ever detected. But I'm going to go ahead and say that there's lots more of these going on right now in every possible direction at a nation-state level and at just a regular hacker level, whether they are malicious or not. So the idea that the U.S. hasn't done this to probably every network on the globe outside of the U.S. and inside of the U.S. corporations is foolhardy. And the idea that the Russians haven't done the same to us and China, vice versa, and all of this, everyone has compromised everyone's network to the point where the idea of there not being vulnerabilities and exposure and espionage going on at high levels of corporations and governments, both directions across the world, should be just considered normal and mostly undetected and kind of unpreventable. Because the reality is the things that need to be done, and some of these things can be done very simply, just don't get done. They cost money, they make things more challenging for the end users, and in the end, security always takes a back seat to things working, and security almost will always take a back seat to profit. So in this regard, for a corporation, I don't know about the government, but let's say you were running a corporate network and you wanted to make sure that this type of an attack on your network was less likely to succeed. You would want to do simple things. You would want to have segregation within your network, meaning these servers or the server core can only do certain things out of the server core, and you would closely control each one of those hosts' ability to egress not only outside of the server core to the rest of the corporate network, and especially the internet, but also within the hosts within the server core. So if this machine is a web server, there is no reason it should be making an SSH call, perhaps, I'm just making these up, unsolicited SSH call to this Linux box, because that's not what it does. Now, it probably makes a SQL database call to this box, and so you should have a map of every host on your network, especially your server hosts, and what each one of them is authorized to do from a network topological level. So if this machine should do SSH, then it should do SSH. If you see other things happening either to or out of that box beyond its intended purpose of SSH, that's something worth looking at. You don't have to go to that level. That's the most complex level, and that's a good place to be. But let's say you just put a bubble around the server core, and you make sure that at least it can't egress to the internet. Maybe at all, quite honestly. Unless your servers on the internet, why your server core needs to be able to egress to the internet would be a challenging question, and one that I got into fights with at many corporations. You should have a DMZ, a demilitarized zone, that has machines and hosts in it that can talk to the internet and talk to the server core. But your server core, in and of itself, the heart and soul of your corporation, should not be able to talk to the internet. I can't tell you how many companies I've had this discussion with that will not go down that path, and this is a very simple path to go down. To make sure that your machines simply can't connect to the internet, that don't need to connect to the internet, it makes life a little more difficult when it's time to update, but it also means that you can also detect the kind of traffic coming out of your server core to ensure that it's not going somewhere it shouldn't. That's a simple thing to do and almost impossible to get done anywhere. I'm sure that's the case in the US government, and I'm sure it's been the case in many corporations that I've worked on InfoSec projects. The next step of that is also your host egress control. So you have your server core, and you have an entire network filled with users. Those users need to talk to the server core on specific things for specific purposes. They probably need to talk to a database server. They probably need to talk to a HTTPS server. They probably might need to talk to an SSH, or maybe the admins need to use SSH to control the routers and network devices inside the server core. You should control the ingress into that so that when a compromised host on your network gets compromised, because it will happen, they can't necessarily just automatically jump into the server core on ports that shouldn't be open in the first place. So you should absolutely control the egress of your server core, but you should also control the ingress of your server core, not just at the port level, but it has to be at the application layer. So for those of you that don't know what that means, TCP/IP has ports on it. Typically port 80 is HTTP, port 443 is HTTPS or SSL. Those are just simple examples, but they don't need to be. You could run SSH on port 443, and frequently that's what happens. Let's say you open up access to the server core and you say allow 80 everywhere, let them do 80 everywhere, HTTP everywhere, and a server inside the server core is compromised but isn't already running a web server. So the attacker, what they'll do on that server is spin up an SSH daemon, open up SSH on port 80, and because you're not doing application layer filtering, monitoring, and control, you're going to see traffic from the workstation to this server on port 80, but you're not going to know that it's SSH going over port 80, not HTTP. Simple constrained controls around segments of your network at the application layer changes the game entirely. Taking that same idea and then putting it to the external or egress network changes everything again. So should your workstations on your network be able to go directly to the internet? Not unfiltered, and not without application layer of visibility and control. Perhaps you want to consider some sort of intermediary proxy or something like that, where the traffic from your workstations go to a machine that's been secured, is inspected, and then allowed out to the internet. All of those things can make a huge difference. The reality is almost no one does any of these things. You have an IT company running a externally facing update server with a password of Solarwinds 123 that doesn't get updated for a year. You have networks that are porous and uncontrolled because it costs money to do security properly. You have no internal segregation between your server core and your workstations. You have probably very minimalistic filtering from your workstations and server core to the internet, perhaps not even application layer, and practically probably not application layer. So you just have best simple port-based control out to the internet. And once a compromise of this nature gets into a network that's managed that way, they can do anything they want, pretty much for as long as they want, and they're probably not going to get detected for a long time, which is exactly what happened here with SolarWinds. So, summary. This probably is way complex for some of you and totally not complex for a lot of you. This is nothing new. This is not a panic attack. All this is a reminder that the reality of the concept of information security on networks that house your data is a foolhardy one. It's not real. It's a lie. No one's doing the right things to do the right things to make sure your data is protected, and it's not going to change until corporations are held liable for not putting in appropriate security measures to protect data like yours. And I mean liable at the highest levels. Nothing will change until executives are held responsible for not putting in the right financing to secure a network the way I'm describing. And the fact that your own government isn't doing that should tell you everything you need to know in terms of what the emphasis is, in terms of spending money to protect the intellectual property and privacy of not only yourself, but your government as well. So I hope that summed this up. I know there's a lot going on about this. I know this isn't a gun topic, but it's absolutely a topic about the reality of today and moving into, unfortunately, the reality of a cyberpunk dystopia, which we thought was fun in video games and fun to watch in movies. It may not be so fun to live in, and this is just one example of many, and there will be many more to come, and the reality call should just be that, it's another day and another breach, and there'll be another one tomorrow. So I hope you enjoyed watching this. I hope this helped you understand what the Solarwinds Sunburst vulnerability is, and I hope it put it into perspective that this isn't the big deal that the media is making it out to be. The bigger argument and statement should be, why is something like this allowed and not detected since March of 2020? And the answer should be, it's not in the cleverness of the attackers. The answer should be, why are we not doing the right things to secure these networks in the first place? And that's not what you're getting from the media. And hopefully that's what you got from me today. If you like this stuff, please consider supporting InRange on Patreon. This is a wholly viewer-only supported project. No sponsors, no advertising, no corporate sponsorship, nothing of that sort. Strictly you, the viewer, support this channel, whether it survives or not. And I am thankful for each and every one of you. And thank you for letting me do this kind of varied content, because you're definitely not going to see this content on any other gun channel, right? So I hope that you enjoyed it, in air quotes, because it's sort of a negative message. I hope it was enlightening. If it was to you, please consider supporting InRange on Patreon. You can find us at patreon.com/InRangeTV. And if you can't totally understand it, we're still going through a global pandemic and now another security breach, amongst other things. Please just subscribe to one of the multiple distribution points that InRange is on. You can find all of them all over the place. We're not just on YouTube. You can find them at inrange.tv/watch. And even more importantly, if you found this video valuable, share it, because the algorithm is not working in my favor. Thanks for watching.